Hey guys, this is Garrett Wong, also known as Ensign Harry Kim from Star Trek Voyager, and you're watching Astronomy Live.
T minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Stop.
Hey guys, this is Garrett Wong, also known as Ensign Harry Kim from Star Trek Voyager, and you're watching...
Hi folks, welcome to Astronomy Live. So tonight I'm going to be doing a tutorial and a bit of Q&A on the new version of SatTraker, version 13, which will be released very shortly, sometime this week, possibly even as early as later tonight or tomorrow, if I can verify that everything's working okay. So there are some important changes to the new version of SatTraker. First of all, it can now handle multi-satellite TLE files. So previously, SatTraker required you to load up a TLE file that only contained the satellite of interest that you wanted to track, and now you can load a TLE file that has multiple satellites and pick the one that you want to track. Additionally, once you've picked the satellite out of the TLE file that you want, it will show the current altitude and azimuth for your location and the current time. So I'm just going to switch camera here real quick. And so this is the camera mounted on top of the telescope right now. And you can see it's currently pointed at a poster on the wall. And I'm going to load up a TLE file here. And we'll get going. So, yeah, that's one of the nice sort of quality of life changes that I've done to SatTraker here to make it a little easier to use in day-to-day use. And one second, let me load up the chat so I can follow along and answer any questions that come up. So one of the things I want to do tonight as I go about showing how to use SatTraker and how to use the new features is I want to answer any questions that come up. So if anyone has any questions, please leave them in the chat and I'll try to respond to that in real time as we go. So SatTraker is also compatible now with a new telescope type. So there's a new option in the telescope type drop-down list, PlaneWave Alt-As. And so this is for PlaneWave L-series mounts. This is intended for altitude azimuth aligned mounts. Eventually I'll add PlaneWave Equatorial as well, but still it will be intended for PlaneWave mounts that use PWI-4, and I believe it's specifically intended for L-series mounts that are kind of ideal for satellite tracking in a lot of ways. So I've added that as an option here as well. Now this is experimental compatibility. I've tested it with the PlaneWave PWI-4 simulator, but it has not been tested on actual hardware yet. However, I have a couple users who are interested in using this with their L-series mounts. So I'm hoping we'll be able to get some actual in situ or in real life data here very soon. In the meantime, I'm going to load up ASCOM Alt-As, as that's the scope I currently have connected to SatTraker, well, connected to the computer anyway, with NextRemote. So I've got my Nexstar GPS hooked up, and I'm going to connect to that with SatTraker, and we're going to go through it. So, first of all, as I mentioned, you can now load multiple satellites in a TLE file. You can select the satellite here with this drop-down list. You can also search for the satellite either by its name or its catalog numbers using the search function here. So I know ISS is 25544, so if I hit enter on that, it pulls that right up. Here's ISS. Now if you enter a number that's not in the file, I'm just going to say 1, 2, 3, 4, 5, 6, whatever, enter, it will say satellite not found in TLE file, and the previously selected satellite will remain the designated satellite. Now it shows that ISS is currently below the horizon, negative 18.9 degrees, negative 19 degrees, azimuth 43 degrees from the location I've got selected right now. So This will be a real-time display. It updates once a second, and it's just whichever satellite you have selected. So you can select again using the drop-down or using the search function here. So now you can have multiple satellites in a TLE file. Even if you only have one satellite, though, you'll still need to select it either with the drop-down or the search function here. So again, you can search for, based on the name, say ISS, or you can search, say here, HST. So now it switches to HST, and I can go back to ISS and then hit enter in the search field, and there it is. It pops it back over to ISS. So one of the first steps is normally to load your TLE file with the select TLE file option, and that can be a text file or a .tle file depending on what you've downloaded. You can get them, you can actually grab them from heavens above just by going to the orbit page and copying the elements, but you'll need to add a third line for the title of the satellite. Or you can download them from spacetrack.org, that's what I usually use, or a variety of other websites. So once you've got your TLE file selected, you can start your camera. So again, camera is selected using this index number here. The first camera, the first Windows camera connected to the computer is generally going to be index 700. So in this case, that's my regular webcam here, looking at my face, and you can see the scope in the background. And then the next camera connected to the computer is actually the finder camera on top of the telescope there, which is just an ELP camera with a C-mount security camera lens. That's index 701. And so when I click Start Camera there, it brings up the finder camera on top of the telescope. Then you can connect your scope. One more thing on the camera. Of course, I also still have the ASCOM camera compatibility option. So it's fairly rudimentary compatibility, but it does allow for connecting to ASCOM compatible astronomical cameras. You can set your histogram width here, so you can stretch the histogram using this. You can alter basically the brightness and contrast of the image a bit with this. You can set the exposure here in seconds, and then you can connect to your ASCOM camera. But for tonight, I'm going to use just Windows-based cameras. And for brighter satellites like ISS or the Hubble, an off-the-shelf USB webcam with a C-mount lens is plenty enough to get the job done. But I know a lot of amateur astronomers who are interested in satellite tracking may have additional astronomical CCD cameras laying around that they just want to use as their finder camera. So for that, I do have ASCOM compatibility as an option. However, ASCOM is slower by its nature and has more CPU overhead than a standard Windows webcam, so I do strongly recommend using a USB webcam for most low Earth orbit satellite tracking operations, if at all possible. It just makes things simpler for now. So I'm going to go ahead and connect to my telescope, and it'll take a second, and now it reports the maximum rates of the axis 0 and axis 1 there at the bottom. So now the next step is to calibrate the finder cam. So we need to know what the image scale is. How many pixels are in 1 degree, or how many degrees or fractions of a degree are in each pixel of the image. What is the image scale? What is the field of view, essentially? And we can do that by tracking a stationary target and getting the telescope to move. So you can set your calibration speed here, and we'll talk about it more in a minute, but it's a little bit different when you select the PlaneWave telescope. The way it behaves is a little bit different. It's not really degrees per second. It is in the case of ASCOM compatible telescopes that use the move axis method. PlaneWave does not actually support the move axis method, though, and this has necessitated offering direct support to PlaneWave, basically speaking its own language. And the control methods are a little bit different with PlaneWave telescopes, so we'll talk about that a little bit later. But this field is still important for PlaneWave, but it will act a little bit differently. It's more like iterations of degrees in motion versus a true rate of motion, degrees per second in this case, for ASCOM compatible scopes. So for example, I'm going to do tracking type feature tracking. So I can now left click and highlight any feature I like on the poster, and I can track that feature. And we can click on it. Now, I've had this question come up before. It doesn't track when I click. Yes, it doesn't track when you click with SatTraker. That's not what SatTraker is for. It's not for de novo tracking, meaning without any information about the orbit or the way the object should be moving, it just is going to track. It's not designed to work that way. It's designed to work with the TLE file, with the orbital elements, to track satellites predictively based on their orbital elements, and then center up on them using the finder camera. But first, as I said, we have to calibrate the finder camera. We have to determine what the image scale is. So we're going to click a stationary target like here, and now we're going to click camera calibration after having set our calibration speed. So I've set it for 1 degree per second, so it should move the telescope 1 degree per second, and it will move relative to this red box here. So this red box, and with the purple circle around it, represents where the finder camera thinks the main telescope view is currently pointed. Not so critical to have that co-aligned with the telescope right this minute, but that's how it's going to move. So it sees the green box is above the red box. It's going to move the telescope such that the green box moves down towards the red box. If I click a target down below the red box, it's going to move the telescope in the opposite direction to move the green box up through the image. It's going to essentially behave in a way that assumes that this red box is somewhere near the center. Doesn't have to be perfectly in the center. As you can see, it's nowhere near the center really, but it's not way off on one side. It's going to assume that it's somewhat reasonably placed, so that if you click a target above it, it makes sense to move the telescope up to move the target down in the frame so that we can sample at least 100 pixels. We want to have enough runway between the target and where we expect it to move, in this case down the image, to be able to travel at least 100 pixels for calibration. So I'm going to click it, and it moves the telescope up, moves the target down. Once it hits 100 pixels, it stops moving, and it says image scale is 0.022 degrees per pixel. So we now know what the image scale is, and it saves that information. And if you click File, Save and Exit and Save Configuration, it will retain that information. So if you haven't changed the magnification of your finder camera since you last saved, it should still be valid. It will also save the position of the center point of the frame, or where it's going to drive the satellite to, this red box, and the purple circle, the crosshair, as well. So we've now calibrated. Now we need to co-align the telescope. So I would move the telescope so that I've got a target in the eyepiece or in the camera that I'm going to record the satellite with, the main camera through the telescope. And let's say I've got it centered up now, and it's actually centered on these little 4 dots here. Okay, let's pretend for a second that I've got the telescope centered there. So to set the center point, I simply click Set Center Point, and I click where I want it, and then I can make micro adjustments with the arrow keys on the keyboard, 1 pixel at a time with the arrow keys. And then when I've got it set where I like it, I can reset the crosshair, and it moves the crosshair to that point. So the crosshair is the purple circle, and you can move that 1 pixel at a time with WASD on the keyboard. Now, why is that there? It's just there as an aid to the user to remind you and keep it and keep a bookmark essentially on where the center of the telescope's field of view really is. Also, I can tell I've left telescope tracking on. This is kind of interesting. If you want to, now this is more useful, I would say, with rocket tracker, where maybe you're pointed at a launch pad for a long time before launch and you don't want the telescope tracking. Most telescopes will let you turn off the tracking. I'm going to go ahead and do that. Tracking mode off, off. Okay, so now the telescope's going to stop tracking. Also, it's important to note that before I started the webcast, I did a pseudo alignment with Next Remote here. So if you're using rocket tracker as opposed to SatTraker, and you are doing de novo tracking, where you're tracking objects without any previous information about where they're supposed to be headed, and you're just doing video-based tracking like this, you do need to, if you're using a Celestron scope like I am, and you're using Next Remote like I am, you do need to do some kind of alignment, or otherwise the telescope will return gibberish back to the program, and image calibration like we just did will not work. So it'll act like it worked, but it didn't really work. It returned gibberish, and the information is nonsense. So you need to align on a star. You don't actually have to point at the star. I just told it I was pointed at Polaris, but I wasn't really. But it doesn't matter. It just gives it sort of initializes the program next remote so that it will return sensible data back to the program, and at least it can know proper relative motion. Okay, so we've got the image calibrated. Of course, if we're going to be doing satellite tracking, we'll need to have actually aligned the telescope, pointed it ideally at 2 stars, but at least at 1 star or 1 target, and provided it with that alignment information so that it can perform slews to coordinates correctly, and hopefully put the satellite in the field of view of your viewfinder at least. Again, this is why I do recommend, I do highly recommend getting one of these ELP cameras or something like it. Any security camera will do if you can pull that image into the to the computer, either with a video capture card or if it's just a USB camera. Something that you can ideally swap lenses on. C-mount lenses work well for this application. I've got a 50mm C-mount lens on there right now with this little ELP box camera, and although it's not super sensitive or high powered, it's good enough, and the wide field of view, as opposed to using say a nice big white refractor like this, like many amateur astronomers may have laying around. This is an Orion ST80, great for auto guiding. Not ideal actually for satellite tracking for a couple reasons, in my opinion. For tracking ISS, for tracking Hubble, for tracking bright, low Earth orbit satellites. In my opinion, it's not ideal. It is doable, but it's not ideal because you have a narrow field of view compared to a 50mm C-mount lens like this. You can see how much of the poster you can see here. It's still zoomed in, but it's not so zoomed in that you are punished essentially with a very unforgiving field of view where you need to hit the target within plus or minus a degree or you're not going to see it. It's wide enough that you can be fairly lax actually on your initial alignment, and it's going to be good enough to get it in that field of view of the viewfinder. And yet you'll be surprised that even at high magnification with this with the scope I've got now, this C11 telescope, which has a 2.8 meter focal length, and I throw a 2.5x Barlow on top of that, it's still actually enough focal length here in this image that you can track at high magnification. I typically put a Blackmagic Pocket Cinema camera on there, which has a 2x crop factor on top of a 2.5x Barlow, on top of a 2.8 meter focal length. I mean, we're talking, here about roughly 14 meters equivalent focal length, and yet I'm able to keep ISS in the frame. So you'll be surprised at what you can get away with in terms of a fairly low focal length viewfinder versus your main telescope view. And I find that's a more helpful combination because it's more forgiving in terms of initial pointing error, and yet it works well enough. You also don't have as much risk of flexure. With an Orion ST80, maybe that's a bad example because it's a fairly low quality refractor, but you do have flexure where the rings that you use to align the scope, the guide scope here, relative to the main telescope, these guide rings are not perfect. I mean, again, it might be because of the quality of materials we're working with here. It's a little homebrew on this end. But you do get flexure with this. With autoguiders, you encounter this. And with autoguiders, and when you're guiding on a deep space target, we're talking about flexure that's an issue at very very small angles over minutes of time. When you're tracking a low Earth orbit satellite like the space station, you're talking about moving the telescope through a dramatic portion of the sky in just seconds, and just a couple minutes. And so flexure becomes a very rapid phenomenon. And whereas the co-alignment point, it might be in one spot in the image at one point in the sky, as you track a satellite, if you get flexure, that spot which is co-aligned with the main telescope is going to drift over here, but you won't even know it, except for the fact that my program is going to keep it where you told it to keep it, which is over here. So it's going to drift out of the field of view of the main telescope, even though it's keeping it right where it ought to be, right here in the viewfinder, your guide scope. But because you're getting flexure, the differential flexing of this telescope versus the telescope it's riding on over here produces a misalignment. And that can be a real problem, even with a C-mount lens if it's really, really big and heavy. I'll give you an example of that. So I've got a bigger C-mount lens than what I currently have attached to the telescope and my viewfinder camera. This is also what I would call overkill. It's a really nice, big TV zoom lens, it's called. It's a 17 to 102 millimeter zoom lens for a security camera. Really high magnification for a security camera, telephoto lens. It's overkill. And because it's so heavy, it actually has flexure. I've seen it. I've tested it with cameras like that one, the little box ELP camera. And when you have these tiny little threads on the back end that's holding onto it, onto the back end or the front end of a ELP camera or some sort of security camera like that, it will sag a bit, and gravity will have a significant effect on it. I mean, not enough that you would notice it by eye just looking at the camera, but when you're looking at the camera's view and you're trying to co-align it to a big telescope like this, where it's pointed horizontally, gravity is going to be pulling on it, versus it's pointed straight up, gravity is pulling with it, you're going to get flexure. You're going to get this relative flexing of the lens, and that's going to produce a misalignment, even though my program is doing the job that it was told to do, which is to keep it at a particular spot, in the picture right here where the red box is. But that's not going to be centered in the main telescope view when you get high over the horizon. So it's going to drift out of your main telescope view very quickly, and that's not what you want. So again, it's actually a little bit of a less is more philosophy when it comes to satellite tracking, in my opinion. Again, I'm maybe giving some hot takes here on this, but just in my experience, you can get a lot done with just a simple, much smaller 50 millimeter lens, or even smaller, but I would stay around 50 millimeters maybe on your finder camera, and that's going to get the job done. I found that to be very reliable. So, all right. So coming back here again, you've aligned you've calibrated your camera. Again, we can do this one more time. Feature tracking. We can click here. We can click camera calibration. Oh, we had an issue there. A little issue there. Could not convert string to float. Might have been something I've been doing, accidentally pressing a keyboard key in the meantime here. Not sure. That's interesting. Oh, I see. Yeah, no, it is. You see my issue? I had entered 1ADW like over here I accidentally pressed keys in this field here, camera calibration speed. So when it tried to parse this as a number, it couldn't, because that wasn't a number, and so it generated an error there. So we can click that one more time. And camera calibration. And there we go. Once again, 0.22 degrees per pixel. We kind of goofed up the lines a bit on the text box here, but no harm, no foul. It's actually okay. So, note to self and to users, be careful that you don't accidentally enter text where there should be numbers, or you'll get weird errors like this. Again, that was PEPCAC. That was problem exists between chair and keyboard and chair. But I entered strings where there should be numbers, meaning letters where there should be numbers there in the calibration speed. But anyway, it did the job. It's calibrated the camera, and so now, in theory, we're ready to start tracking a satellite. So in this case, neither of these two satellites are above the horizon, so it's not going to be very successful with tracking, but you get the idea. All you would have to do is click Start Tracking Satellite, and then click on your target when it comes into view in the viewfinder camera, and it will center that up. Now, I do want to talk a bit about how this works with PlaneWave telescopes. So, if you select PlaneWave as the telescope type, again, I can start camera, and I'm going to pull up PlaneWave software here. So I've got PlaneWave running in the background. Now, at the moment, and I don't know that this makes the most sense for the users of PlaneWave telescopes, but I'm assuming that guys and girls who are using PlaneWave telescopes are normally connecting to them with software like this, the PlaneWave interface. I don't know how standard in the industry it is to connect with other software, but I'm assuming that's fairly standard, where you can connect to your telescope with you know, a third-party program, or I guess first-party in the case of PlaneWave, and control it that way. In which case, my software doesn't really need to connect, in the sense that it's not going out and sort of establishing the connection between the computer and the telescope. That connection should already be established, I believe. Now, I can change my program to do that, to actively establish the connection and disconnect as well, turn off that connection to the telescope. And it does that in the case of, say, ASCOM or the AUX200 Classic, so on and so forth, where it is really establishing a connection and then dropping that connection when you connect and disconnect. In my limited testing of the simulator, it seems like that behavior may not be desirable when it comes to PlaneWave scopes. And I'm hoping for feedback here from people who use PlaneWave mounts. Let me know if that makes sense or not, if it makes sense for my software to establish the connection and then drop the connection to the telescope. I feel like that might not be desirable, because you've probably got other planetarium software talking to the telescope in the background, and my software is just sort of going to piggyback on that and also talk to the telescope, but not to the exclusion of other software. And at the end of the session of tracking a satellite, when you click disconnect here, you probably don't want it just dropping the connection to the telescope for the night. Maybe you do, maybe that's all you intended to do for the night, but I feel like that's presumptive of me to do. So at the moment, I have it configured so that it's not actually going to establish the connection. So you will need to have connected to the mount with a third-party program. And again, this is all behavior that I can change if that's not desirable. If you would like the software to establish the connection free of any other software, we can do that. We can set it up that way. It's a very simple change, but I feel like maybe that's not desired. So with that said, I'm going to go ahead and connect, and it says max rate 20 degrees. That seemed to me to be sort of one of the possible maximum rates of an L-series mount, but I'm not super familiar with the specs. It seems like some of them may be at 50 degrees per second max, some of them might be at 20. I took the more conservative 20 degrees per second slew rate max. Even then, the way it's going to work is not quite the way my software has typically worked with other mount types. So with other mount types, for example, calibration speed, when I told it 1 degree per second, it delivered exactly 1 degree per second from the Celestron, because it allows me to directly control the drive rates. Not so with PlaneWave. It is a little bit different. So for example, when I do camera calibration here, what you're going to see is it's going to move the green crosshair here. Those of you who have a PlaneWave telescope probably already know how this view looks in PlaneWave interface, but for those who don't, it's going to move this green crosshair here, and it's going to do so in sort of a iterative stepwise way. So again, it's going to look for 100 pixels of motion of whatever you're tracking, the stationary target, In this case, because it's actually connecting to a simulator, not physical hardware, and definitely not physical hardware the camera's riding on, it's not actually going to move the box here. It's going to try, but it's not going to actually move. So it'll just keep doing it forever. It'll keep trying until it hits 90 degrees straight up in the simulator, because it's not actually going to physically move anything here because I'm connecting to the simulator. So I'm going to have to sort of manually trick it by clicking down here to get it to lock on down here and make it think that it's moved the box. To simulate the motion of going through the camera calibration step. But it's going to do so, like I said, in a stepwise fashion, where every 5 seconds it will issue a new go-to command. And it will go to coordinates that are this many degrees away from the current coordinates every 5 seconds. So whatever you put in the calibration speed box, that will be the number of degrees north or south, or really higher or lower in altitude, that it will keep stepping the telescope through as it calibrates. And once it hits 100 pixels displacement or more, it will stop. At that point, it will stop the telescope, and it will calculate the image scale. So I'm going to go ahead and click camera calibration, so you can see it's generating new coordinates. It's moving the green crosshair 1 degree at a time, comes to a stop. A few seconds later, it issues a new go-to command. It keeps trying to go and go and go because it's trying to move this green box, but it's not moving. So it's just going to keep going till I click down here and say, okay, you moved it that far. And then boom, it says, oh, okay, well, I've now crossed 100 pixels or more. So the image scale is now calculated as this. It's not really this, but it's just, that's what the result of the math is based on how long I let it go there, where it was trying to move the box 1 degree at a time. So that's all there is to that. So that's with PlaneWave. Now it's ready to start tracking now with PlaneWave. So if I tell PlaneWave, okay, Hubble is now 3 degrees above horizon, it's just crossed the horizon, I'm going to start tracking satellite. It will start tracking the satellite. You can see it's moving down towards the horizon. It's locking onto it. Trying to anyway. It's going to have to go all the way around to 270 degrees azimuth. So it's spinning around, getting over to where the satellite is. And the way this works with PlaneWave, for those who don't know, PlaneWave natively supports ingesting TLE files. It will take in the orbital elements of the satellite and do all the tracking for you. What my software will do is provide an additional ability to correct the tracking on top of what the PlaneWave software will do. PlaneWave right now is just doing open loop tracking, meaning it's taking in the orbital elements, it's outputting what it thinks is the correct velocity, the correct position to keep it centered in the view, but it's not doing any correction based on what your viewfinder or your main camera is necessarily seeing. That's what SatTracker is for. So with SatTracker, you can click where you see the satellite in your viewfinder and center it up at high magnification. So it's tracking what it thinks is Hubble right now, and you can see delta as, delta out. Delta as is almost 360 degrees, so it's just it went around the long way, and I'm not sure why it did that on this view, but you saw like it went all the way around here. But basically, it's almost zero really. It's almost 360 or 0 degrees azimuth difference, and delta out is very low here too. This is a delta from SatTracker's calculation of where the satellite is, not where PlaneWave thinks the satellite is. They're actually very similar values, but they're very slightly different based on how they're doing the calculations from the orbital elements. Okay, so this isn't really super important. It's not really driving the telescope. It's just letting you know it's either in good or bad concurrence with where it sees the telescope currently pointed versus where SatTracker thinks the satellite is. And then let's say Hubble were actually over here in the viewfinder and it's not where you want it to be. In the main telescope view, you can click here and it's going to start driving. It's trying to center up on where it sees up and to the left, up and to the left. See, this is up and to the left of the main telescope view, and it's driving the crosshair further up into the left, trying to catch up to it, and it's just not having any luck because, well, it's connected to a simulator. It's not connected to physically moving hardware. So if I click down below, let's say down to the right a little bit, it's going to move the green crosshair down to the right more and more and more, and it's going to keep trying to chase a phantom target, but it's not actually controlling this camera's view, this viewfinder camera. Of course, it's connected to the simulator, but it does act like it ought to. It's driving in the directions it's supposed to be driving in order to theoretically track the target. So if this were connected to physical hardware, I'm fairly confident this would actually work. It does work with other telescope types, and now I've ported it, at least in theory, to work with PlaneWave. So we'll need some willing volunteers who are brave enough to try this out on their L-series mounts. But again, there are a couple users who expressed interest in this for their PlaneWave mounts, so I'm really eager to see what they're able to achieve with their mounts and their telescopes using SatTraker with this new version 13. So again, I'm going to click over here to the left, and it's going to move the crosshair really to the left. You have to picture the western horizon here. Like, imagine you're facing the western horizon. The green crosshair is moving to your left in that case. And then if I click over to the right, it says, oh, now he's way over here. I'm going to chase it. It's not going to be able to catch up to it, of course. So that is how that works. Again, it might need some bug fixing, I suspect. I'm only able to test it in simulation here, not in real life. So it might overshoot, it might, act a little funny, but I think it'll work. And if there's any issues, we'll fix those bugs and get it running properly. But at least with the simulator, it seems to be doing what I expect it to be doing, like what it should be doing in order to track a satellite. So we'll see how it does in real life. And again, I'll be compiling this new version and releasing it on the community tab for all channel members to download here very shortly. If I don't get time to get it uploaded tonight, it'll be up no later than tomorrow. So check back for that. All right, let's see what people in the chat are saying. KaiserCube says, my ZWO ASI Air Plus and 120mm Mini is still on back order. Ooh, yeah. Those are really awesome cameras. Again, for this application for a viewfinder camera, in my opinion, that's overkill. So depends on what you're planning to do there. Like if the 120mm Mini is to be like the main telescope view with the ASI Air, I think that's perfect. That would work great. Whether you want to just have that as the one and only camera, you could try that. You can also record video here, so that is a functionality available as well. It'll record a video file for you, I think with a timestamp anyway, if you check this box, and then when you uncheck it, it stops the recording. Just make sure you uncheck the box and stop the recording before you shut down the program, or it might corrupt the video. So yeah, that's the only trick there. So yeah, again, it's happily tracking where it knows Hubble is from this location at this time, and it's just happily going along there. And again, you can click in certain directions. Like I'm clicking here, like it thinks, oh, it's higher in altitude than the telescope, so I'm going to go up back towards the zenith, and it's going to keep chasing it, but it's not going to be able to get to it. Also, because of the way PlaneWave works, it's issuing this as an offset from the target location. So it's saying, okay, I need to offset the expected target coordinates by whatever this amount is in the viewfinder based on the image scale. It will then spend a second issuing that correction before SatTraker reassesses and says, okay, you're still this far away, so keep going. See, it's driving the crosshair further and further and further up. Keep going. You're still not there. If you right-click, it undesignates that target, and it goes right back to no offset. So it will, if you click and you click the wrong thing, or you misclick and it goes off in a crazy direction, just right-click, and it will go back to reverting to only being based on the TLE file, just based on the orbital elements alone, and then you can click on your target again and try to get it back in the frame. So left click to designate the target, right click to undesignate the target, mouse wheel to grow the target or shrink the target box. That can be helpful for excluding any other relatively bright stars that might be passing close to the target, but also having a larger tracking box lets you more leeway in getting it over the target and clicking it. So just keep that in mind. But yeah, that's really all there is to it. And then when you're ready to stop, you can click Stop Tracking Satellite, and it will immediately issue a stop command to the telescope, so it stops the telescope from moving. So you can see here, the telescope is changing its right ascension coordinates because it's actually not tracking right now. It actually issued a stop command to the telescope. If I click track over here, it actually engages tracking and the coordinates stop moving. And then I'm going to say stop, and it will say, okay, I'm going to stop the telescope, and then the coordinates change because the sky, the Earth is actually rotating, so the coordinates that the telescope's pointing at are actually changing because the telescope is not moving at all at that point. So again, you can click Start Tracking, and it says, okay, I'll go back to Hubble. Okay, so now it's pointed at Hubble. As you can see, delta as, delta out, very low numbers. And you can click, again, Stop Tracking, and it immediately stops. And if you click Disconnect Scope, on PlaneWave, this will also issue a stop command. So when you click Disconnect Scope, if you encounter any issues and you want to stop it right away, you can click both or either Stop Tracking or Disconnect Scope. Both will issue stop commands. So again, I'll start tracking Hubble here, and I'll just rudely disconnect the scope suddenly. Boom. It actually stops the scope. And then delta as, delta out start increasing because the scope's not actually moving. So stop tracking. Yeah, and so it says, hey, connect to the scope first. What did you do that for? You tried to stop it, and I'm not even connected to the scope. Yeah. So both will issue stop commands to the telescope as a safety measure if you encounter any issues there. All right. Hi, Lillian. I'm doing good. You can use this software on something like an AZ-EQ6 mount. So an EQ6 mount, you can try. I've not heard terribly good reports with the EQ mounts, the EQ6 type mounts. It is supposed to be compatible with ASCOM, but in my experience, it seems like it does not behave the way Celestrons do, and I still don't understand why, but they don't seem to behave well with move access methods. And I've heard talk on forums about the way they behave, where at high speeds and low Earth orbit satellites like the space station require the telescope to move at high speeds, say a degree per second, on that order of about a degree per second of motion. Or even higher as you get close to the zenith on an ALTAS mount. When it's operating at high speed like that, I've heard that you cannot change the speed smoothly. You can't tell it at one moment, okay, I want you to move at exactly 1 degree per second. Now, a tenth of a second later, I need you to drop that down to 0.99 degrees per second because ISS is slowly decelerating in the sky, which it will do. It'll get faster as it rises. It'll get slower as it goes away from you, that kind of thing. You can't smoothly tell it to change velocity like that. It won't let you. It has to come to a complete stop. Then you can change velocity. Then you can start moving again. That's just not tenable for satellite tracking. But I have seen others do it. So I know I know in theory these scopes are supposed to be capable of that kind of variable rate tracking. But the question is, are they capable of that kind of variable rate tracking at high speed? And I've heard, at least on one forum I saw, where they said, no, it can't actually do that. It will not work. It will force the telescope to come to a complete stop before changing the speed for high-speed tracking, which is kind of silly to me, but that's what I've heard. If that's true, then no, there's nothing I can do to get it to work with that kind of mount. I'll keep investigating that, though, and if I find that's not true and there is a way to make it work, I'll try to make it work. But at least from what I've seen so far, it seems like I'm sort of on a wild goose chase on the answer there, because it may not be possible with those mount types. So yeah, the current version, the compatibility it adds, unfortunately, is just for PlaneWave telescopes. It's not for EQ6 type telescopes. If I can get there, if I can find a way to make that work with those scopes, maybe by speaking their language directly, I'll let you guys know. I know a lot of people who have scopes like that, who would very much like it to be compatible with their scopes. So if I get there, I'll let you guys know. But at the moment, I have not found the way to make that work with those scopes. Tweaking the layout in the version I had, but that was months ago. Can't recall if there's a limit for the text fields, but probably. Yeah, I mean there is a limit to the text fields. I don't know what text fields you would need even more space on. Like you could see here, I've got a pretty darn specific latitude and longitude put in here. Gee, I wonder where that goes. Maybe something of historical importance or interest, Easter egg there for you. But yeah, no, I don't know what text fields would need. Oh, maybe this down here, maybe this field. And oh, by the way, for those who want to know, like you can also highlight and copy this whole log of information with Control-C and paste that into a notepad with Control-V. So if you want to look back over what happened during your tracking, you can copy this. And I ought to actually implement a proper logging feature that allows you to automatically, or at least at user command, save this as a text file, but haven't done that yet. Another feature on the to-do list, but yeah, at least for the moment, you can manually copy this off and paste that in a text file if you want to review that after the fact. So yeah, that's pretty much it. That's a quick overview and tutorial of how SatTraker version 13 works. Hope you guys find it useful, and I can't wait to retweet or share your videos if any of you get any footage of satellites, especially with the new PlaneWave compatibility feature. Let me know. So I'm going to wrap this up, but glad I could go over this with you guys and just show you how the new version of SatTraker works. So again, this will be released to all channel members on the community tab here shortly, and you can go there and get the link and download that. I'm not currently updating the source code on GitHub due to some issues, but I will be releasing the compiled executable of this version for channel members. So if you haven't already and it's of interest to you and you have a telescope, either a Celestron or PlaneWave or something that could use the software, you could download, certainly for any Celestron or ASCOM compatible scopes that use the move axis method, you can go on the GitHub and get the older version and just verify that it's functional and works with your scope. But if you want the newest version with the new features, if you want to get that, if you join as a channel member, you can download that. And if you don't want to stay as a channel member, that's fine. You can immediately unjoin from channel memberships, and you get to keep the file. You can use it for as long as you like. There's no sort of paywall once you get the program. So thank you very much for watching, and I'll see you guys soon. Till next time, clear skies, folks.